6 full moons could sit side by side inside it. It has been above you your whole life. On a clear night, its light reaches your eyes without a telescope, without a lens, without anything. And still, almost nobody has ever seen how much of the sky it truly covers. Tonight, we are going to spend a long, slow while with one of the largest things beyond our own galaxy that your unaided eyes can reach. The Andromeda Galaxy. 2.5 million light-years away, and still wide enough to span 3 little finger widths of your sky. That is the puzzle we sit inside tonight. Hold your hand out at arm's length and lift your little finger. That fingernail is about 1 degree of sky. It is wide enough to cover the full moon twice over. Andromeda is 3 of those fingernails, laid end to end. 3 degrees. 6 full moons in a row. That is not a photograph. That is not what a telescope would show you. That is the real width of the real thing, sitting in the real sky above your roof, tonight, whether the clouds are in the way or not. And yet, if you walked outside and looked straight at it, you would see a faint gray smudge, smaller than your thumbnail, so dim you would not be sure your eyes had found anything at all. Before we go further, where in the world are you listening from tonight? A city where the sky never really goes dark? A quiet road somewhere with no streetlights? A room where the window is open and the night is coming in? I always like knowing. And if this kind of slow, patient looking is something you want more of, a like or a subscribe helps other people who need a quiet voice at night find their way here. Now settle. Loosen your shoulders. Let your breathing get slower than your thinking, because over the next 3 hours, we are going to answer one question, slowly, from every side. It is 6 moons wide, so why can you barely see it? Let us start with what is actually there, on an ordinary night, above an ordinary roof. Go outside in autumn once your eyes have stopped expecting anything. Look up and to the northeast, into that part of the sky where the stars are scattered rather than arranged. There is a shape up there that looks like a crooked letter W, tipped over and hung out to dry. And a little below it, drifting in a stretch of sky that most people walk under without ever raising their chin, there is something that is not a star. It is a smear. A soft gray oval with no edge. Nothing about it announces itself. It looks like a thumbprint left on cold glass, the kind you only notice when the light falls at the right angle, and which disappears again the moment you look straight at it. That is the thing. That faint, uncertain, easily missed patch of gray is a galaxy of roughly 1 trillion stars, and it is one of the widest distant galaxies the unaided eye can reach in northern skies. Sit with that for a moment before we do anything with numbers. The light that is landing on the back of your eye when you look at that smudge left its home 2.5 million years ago. It did not leave when the pyramids were being cut. It did not leave when the first cities were drawn in mud. It left before there was anything on this planet with a face you would recognize as a human face. It has been traveling without pause, without slowing, across an emptiness with nothing in it, for the entire length of our becoming. And tonight it ends its journey by falling into your eye, in your garden, above your roof, while you stand there in a coat you did not zip up properly. That is the first strange thing about Andromeda, and we will come back to it. But it is not the strange thing we came for. The strange thing we came for is the size. Because when you look at that smudge, your eye tells you it is small. It reads as something you could cover with a thumbnail. Something modest, tucked away, minor. A gray coin dropped in a very large room. Your eye is wrong. Not slightly wrong. It is wrong by a factor that is genuinely difficult to hold in your head. Andromeda spreads across 3 degrees of sky. The moon, one of the largest obvious things people ever point at, spreads across 1/2 of 1 degree. 6 of them, laid edge to edge in a line, would still not reach across it. So the smudge is not small. The smudge is the brightest fraction of something enormous, the glowing middle of it, the crowded center where the stars are packed too tightly for your eye to separate. Everything else, the whole vast spiral spreading out from that center, is up there too. It is simply too faint for your eye to register, and so your brain does the only sensible thing available to it and draws the edge in tight around the part it can see. You have been looking at a fragment and calling it the whole. There is an experience astronomers describe that is worth trying because it makes the point better than any diagram. It is called averted vision. You look slightly to the side of the smudge, not at it, past it. And as you do, the smudge grows. It becomes larger and softer and less certain and considerably more real. Look straight at it again, and it shrinks back down. Nothing changed in the sky. What changed is which part of your eye you pointed at it, and we will get to why that happens, because it turns out to be one of the reasons Andromeda hides so well. But notice the feeling of it. You are standing still. Andromeda is doing nothing. And its size is changing depending on how you look. That is not a property of Andromeda. That is a property of you. This is what makes Andromeda worth 3 hours of a quiet night. It is not rare. It is not hidden behind an instrument you do not own. It is not somewhere you have to travel to. It is right there, most nights, above most roofs on the northern half of this planet, and it is enormous, and almost nobody has ever seen how enormous, including most of the people who have looked directly at it. So when we ask how big Andromeda is in our night sky, we have already found that there are 2 answers, and they do not agree. There is the answer your eye gives you, a gray thumbprint, easy to miss, easy to forget. And there is the answer the sky gives you, 3 degrees, 6 moons wide, a stretch of night that takes 3 of your little fingernails, laid end to end, to cover. Both answers are true. That is the problem. And the space between those 2 answers is where we are going to spend tonight. To get anywhere near it, though, we need something we do not usually have. We need a ruler. Not a ruler for measuring distance. Distance is easy. It is only a very large number. We need a ruler for measuring how much of the sky a thing takes up. A way of saying this wide about something you cannot walk over to. It turns out that such a ruler exists, that it is very old, and that you are carrying one with you right now, attached to the end of your arm. When you want to describe how large something is, you normally reach for a comparison you can hold. This is the size of a door, that is the size of a coin. Andromeda refuses to cooperate with that. It cannot be held, and it sits at a distance you have no intuition about whatsoever. So we do something older and simpler. We stop asking how big Andromeda is and start asking how much of the sky Andromeda covers. Imagine the whole sky as a dome resting on the horizon all around you. Not a photograph, not a flat ceiling, a bowl with you at the bottom of it. From one horizon, up over your head, down to the opposite horizon, is 180 degrees. Straight up from where you stand to the horizon in any direction is 90. Those are the two numbers that matter, and once you have them, the sky becomes measurable and Andromeda becomes measurable with it. A degree, then, is one small slice of that dome. And here is the part that surprises people. It is much smaller than it sounds. Hold your arm straight out. Make a fist. That fist, seen at arm's length, covers about 10 degrees of sky. Open your hand and spread it wide, thumb to little finger, and you have about 25. Hold up 3 fingers together, and you have around 5. Hold up your little finger alone, and you have 1. This works for you, and it works for a child, and it works for someone twice your height, because a taller person has a longer arm to match a wider hand. The ratio does the work. It is one of the very few measuring instruments that has never needed to be manufactured, calibrated, or bought. Every human being who has ever lived was issued one at birth. Almost none of them ever found out they were carrying the only tool required to measure Andromeda. So now we can be precise about the sky in a way that costs nothing. The full moon, the object that dominates every night it appears, the one people photograph badly and describe as huge, covers half of 1 degree. Half your little fingernail. If you lift your hand tonight while the moon is up, you can cover it completely, and you will have a good deal of fingernail left over. Almost nobody believes this until they try it. The moon feels enormous. It feels like something you could not possibly hide behind a fingertip. And yet the measurement is not in dispute, and it is easy to check. Every person who checks it comes away slightly unsettled. It means their eyes have been quietly exaggerating one of the most familiar objects in their life, every single night for their entire life. Hold that thought carefully, because we are about to run exactly the same test on Andromeda, and it is going to come out the other way round. The sun, by the way, covers almost exactly the same half degree. That is the reason total eclipses happen at all, and it is a coincidence with no cause behind it. The sun is 400 times wider than the moon and sits 400 times further away, and those two numbers happen to cancel. Nothing arranged that. It simply is the case at this moment in the long life of this planet, and it will not always be. So we have our ruler now, and we have our first 2 marks on it. The moon, half a degree. The sun, half a degree. Those are the largest things most people can name in the sky, and they are, both of them, small. Everything else you have ever pointed at is smaller still. Jupiter, at its closest, is about 1/40th of a moon, a bright dot and nothing more, no matter how long you stare. Jupiter and Venus are still only tens of arcseconds across. Every star in the sky, including the ones with names and stories, is a point with no width at all. The twinkle and the little spikes are your eye and your atmosphere, not the star. This is the sky as everyone knows it, an enormous dark bowl with a half-degree moon in it, and nothing else you could measure. And it is completely wrong, and the thing that proves it wrong is Andromeda. Because the faint gray smudge, the one that looked like a thumbprint, the one that disappeared when you looked straight at it, the one you have to be told about before you can find it, is 3 degrees, not 1/40th of a moon. Not half a moon. Andromeda is 6 of them. Sit with the arrangement of that for a second, because it is genuinely upside down. The brightest object in the night sky is one of the smallest things in it. And Andromeda, which is so faint that most people have never knowingly seen it, is 6 times the width of the brightest thing there is. Everything your eyes have taught you about the sky has the ranking backwards, and Andromeda is the proof sitting above your roof. Which raises a question we should probably deal with before we go any further, because it is the one your own eyes are asking right now. If the moon really is only half a degree, why on earth does it look so big? The reason to spend a whole stretch of tonight on the moon, in a video about Andromeda, is that the moon is our ruler, and a ruler you do not trust is worse than no ruler at all. Every number we say about Andromeda from here on is going to be quoted in moons. So the moon had better be solid. Let us settle it. Take a grain of rice. Hold it out at arm's length. That grain, at that distance, is roughly the size of the full moon in the sky. Not roughly in the sense of close enough, roughly in the sense that you can go outside and check, and people do, and the grain wins every time. The number, if you want it precisely, is about 31 arc minutes. An arc minute is 1/60th of a degree, which is the unit you reach for when degrees become too coarse. So the moon is 31/60ths of a degree across, which is a hair over half. It varies a little, because the moon's path around us is not a perfect circle, so some full moons are genuinely larger than others, by about 14% between the largest and the smallest. Nobody has ever noticed this without being told, which should tell you something about how reliable our sense of size in the sky really is. And yet the moon looks enormous, particularly when it is low, sitting just above a row of houses or the far edge of a field, orange and swollen, and close enough to touch. That low moon is very nearly the same angular size as the high moon, if anything, slightly smaller near the horizon, because it is slightly farther from you. It is not closer. If anything, it is very slightly further away, because when it is on the horizon, you are looking at it across the width of the planet rather than straight up through the thinnest part of the air. You can prove this to yourself, and the proof is one of the small pleasures available on any clear night. When the moon is sitting fat and orange on the horizon and looks impossibly large, hold up your little finger and cover it. Then wait 3 hours until it is high overhead and looks ordinary and small, and cover it again. Same finger, same coverage. The change was never in the sky. It is called the moon illusion, and the honest position is that after 2,000 years of people writing about it, there is still no single agreed explanation. Something about having a horizon full of objects, roofs, trees, hills, gives your brain a chain of reference points, and it decides the moon must be far away, and therefore, to look that big, must be vast. Take the reference points away, and the moon shrinks back down. Photographers know this. Photograph the horizon moon, and you get a small disk and a disappointed feeling, because the camera has no brain to be fooled. Now, think about what that means for Andromeda. Your eye can be that wrong about the moon, an object you have seen thousands of times, with a hard, bright edge, one you could point at without hesitation. Against Andromeda, it has no chance at all. Andromeda is faint, it is gray, it has no edge, and you have almost certainly never been shown it. Every condition that lets your brain make a decent guess is missing. Your eye does not measure. Your eye estimates, using whatever context it can find, and against Andromeda, it has no context whatsoever. This is the quiet argument underneath tonight. We are not going to trust our eyes about Andromeda. We are going to trust the ruler, and we are going to hold the ruler up, and we are going to read what it says, even when it says something absurd. So the moon is half a degree. 2 moons make 1 degree. Your little fingernail at arm's length is 1 degree. And whatever your feelings on the matter, that is the truth of the sky, checkable tonight by you with no equipment and no permission. So when we ask how big Andromeda is in our night sky, we now know 2 things we did not know an hour ago. We know how to measure it: the hand, the fist, the fingernail, the degree. And we know that our own sense of size is not merely imprecise, but actively misleading, in a direction that always makes bright familiar things feel too large, and faint unfamiliar things feel too small. Andromeda is one of the faintest, least familiar large structures available to a human eye, which means it sits near the worst point of that bias, the point where the error is largest and runs entirely in one direction. That is the trap that has hidden Andromeda above so many roofs for the whole of human history. Not distance, not size. A bias in the estimate, always pointing the same way. Because if the moon, half a degree, feels enormous, then Andromeda, 6 times wider, should feel overwhelming. It should be the first thing anyone mentions about the night. It should be the thing children are shown before they are shown anything else. And it is not. It is not even the 10th thing. Most people who have looked directly at Andromeda have not known they were looking at it. Before we can understand why, there is one more stop to make. Because Andromeda is not the only large, faint thing up there. There are others, sitting in plain sight, quietly bigger than the moon, and once you know they are there, the sky stops being a scattering of dots and becomes something with structure in it. Once you have a ruler in your hand, the sky starts giving up things it had been keeping from you, and Andromeda turns out to have company. Because it turns out that the half-degree moon is not the largest thing up there. It is only the largest thing that is obvious. And obvious, as we have just established, is not a measurement. Start with Orion, because almost everyone can find it. 3 stars in a short straight row, tilted, unmistakable once you have seen them once. Below that row hangs a fainter line of stars, and the middle one of those is not a star. Look at it through nothing at all, and it is a fuzzy point. Look at it on a dark night with your eyes properly adapted, and it stops being a point and becomes a small, pale cloud. That is a nursery, a vast bank of gas and dust, with new stars igniting inside it, close enough that we can watch it happening. Hold your fingernail up to it. The nail covers it, but not by much. That cloud spans about 1 degree of sky. 2 full moons side by side, and still only a third of the width of Andromeda. It has hung in the same place every winter for the whole of recorded history, in one of the most looked at parts of the sky on this planet, and it does not look large. It looks like a smudged star. Now walk your eye across to the Pleiades, the little knot of stars that people notice out of the corner of the eye and mistake for a tiny dipper. Most people see 6 of them, some see 7, a few in very dark places see more. That knot spans about 2 degrees, 4 moons across. 2/3 of Andromeda. 4 moons, and it reads as a small cluster you could cover with a fingertip. Go outside and try to cover it. You cannot. The illusion breaks the moment the ruler comes out, and it breaks the same way every time, for the Pleiades and for Andromeda alike. There is more, and it gets stranger. The V-shaped face of Taurus, just next door, is a genuine cluster of stars sitting nearer to us than the Pleiades, and it sprawls across something like 5 degrees. 10 moons. 3 fingers held up together, wider than Andromeda, in fact. Nobody describes it as large. Everybody describes it as the V. And if you have ever stood under a southern sky, the sky over Chile, over Namibia, over the far south of Australia, there are 2 soft patches up there that look like torn-off pieces of cloud that never move. Those are galaxies, satellites of ours, and the larger of them spreads across roughly 10 degrees of sky, 20 moons. More than 3 times the width of Andromeda. A galaxy, 20 moons wide, and people who live under it their whole lives grow up thinking of it as a smudge in the sky with a name. So this is the picture we should be carrying now, and it is not the picture most of us grew up with. The night sky is not a black sheet with bright dots pinned to it and 1 large moon. The night sky is full of enormous, soft, faint structures, nurseries, clusters, whole galaxies, Andromeda among them, spread across whole degrees of sky, layered on top of each other, present every clear night, and almost entirely invisible. It is like walking into a room you have used for years, one you would have sworn was nearly empty, and having someone bring a lamp in from a different angle. Nothing has been added. The furniture was always there. You simply had no light coming from the direction that would show it to you. And notice the pattern, because the pattern is the answer we are circling. There is a pattern in the objects we have been looking at tonight. The wider, more diffuse structures tend to spread their light more thinly across the sky. The things that leap out at you, the planets, the named stars, arrive as points. The wide, soft ones, Andromeda included, arrive as a wash. That is not a coincidence, and it is not bad luck. It follows from how light spreads. And it is the reason Andromeda, 6 moons wide, can sit above many northern skies and go unnoticed. So when we ask how big Andromeda is in our night sky, we can now put it in company, instead of leaving the number stranded on its own, where it sounds impossible. 1 degree, the Orion Nursery. 2 degrees, the Pleiades. 3 degrees, Andromeda. 5 degrees, the face of Taurus. 10 degrees, a satellite galaxy in the southern sky. Andromeda is not the largest thing in the sky. It is not even close to the largest. Andromeda sits comfortably in the middle of a list of soft giants, most of which you have already looked at without knowing. What makes Andromeda different from the others on that list is not its size. It is its distance. Everything else in that list is either inside our own galaxy or holding on to its outskirts. Andromeda is the only major galaxy on that list that is not a satellite of our own, a separate structure, 2.5 million light-years off, and still managing to be 6 moons wide, which makes the real question sharper, not softer. Because it is not. How can something be that big up there? Plenty of things are. The question is, why so many wide, diffuse structures are faint, while the things that immediately catch our eyes tend to concentrate their light into smaller areas? And why our eyes, in particular, are so badly built for the wide, soft half of the sky? The answer to that turns out to be a single idea, and it is the idea that unlocks the whole night. It has an unglamorous name. It is called surface brightness. And it is the reason Andromeda, 1 trillion stars strong, can be dimmer than a single ordinary star sitting a few degrees away. Here is a fact that ought to be impossible, and is not. Andromeda contains something in the region of 1 trillion stars. The exact figure is argued over, and the argument is not important tonight. What matters is that Andromeda is an unthinkable number of suns, burning all at once, all in the same place. And if you go outside and look at Andromeda, any single patch of it is fainter than an ordinary-looking star sitting a few degrees away. Not the whole of it. Added up, all of Andromeda's light together would make a perfectly respectable, naked-eye object. The trouble is that none of it arrives concentrated. Spread across its full width, every individual patch of that glow sits below what an ordinary star delivers in a single point. Your eye finds those stars instantly, and has to be coached into finding Andromeda at all. The reason is not that Andromeda is dim. Andromeda pours out an amount of light that has no useful comparison. The reason is that the light arrives spread out. Think about a spoonful of honey. Put it on one slice of toast and you get a thick golden layer, obviously there, impossible to miss. Take the same spoonful, exactly the same amount, not one drop less, and spread it across an entire kitchen table. It is still all there. Nothing was taken away. But now, there is no golden layer anywhere. There is a faint stickiness you would only find by running your hand over it, and from across the room, the table looks clean. That is what has happened to Andromeda's light by the time it reaches you. A star, however bright, arrives as a point. All its light lands in essentially one spot on the back of your eye, and that spot lights up, and your brain says, there. Andromeda arrives smeared across 3 degrees. Its enormous output gets divided over an area 6 moons wide, and every individual part of that area receives only a thin wash of light, thin enough that it sits right on the edge of what a human eye can register at all. This is why the smudge you see is only the middle. The center of Andromeda is where the stars are crowded most densely, so that is where the light per patch of sky is highest. The central region clears the naked eye threshold most easily. Much of the outer disk falls below it. It is not absent. It is arriving, tonight, on your face, in the same quantity it has arrived for 2.5 million years. Your eye simply cannot get a signal out of it. Notice how completely this reframes the question. We started tonight assuming Andromeda was faint because it was far. It is not. Distance is barely the point. Take Andromeda and squash all its light into a single point. Leave it exactly where it is, 2.5 million light years away. Change nothing but the spreading, and it would change completely. It would look like a clear, naked eye point of light, rather than a diffuse haze, far easier to notice, though its total light would be unchanged. Andromeda is not hidden by distance alone. Most of it is hidden by how widely its light is spread. And here is the part that catches people off guard. This does not improve with a telescope, in the way people expect. A telescope gathers more light, which is why it can show you faint stars you could never otherwise see. But a telescope also magnifies, and magnifying spreads the light over a wider area again. For a point of light, the first effect wins, and the star leaps out. For an extended object like Andromeda, that gathered light is also spread across a magnified image, so the surface does not simply get brighter the way a point-like star can. Which is why beginners at a telescope are so often quietly disappointed by Andromeda in particular. They have seen the photographs. They put their eye to the instrument, expecting the photograph, and they get a gray oval. Larger than with the naked eye, yes. Clearer at the edges, yes. But gray and soft and nothing like the picture. Nobody lied to them. We will get to what the photographs are actually doing later tonight, and it is more interesting than a trick. There is a small irony here worth naming. For taking in as much of Andromeda as possible in one view, low-power binoculars can be more satisfying than a high-magnification telescope. Less magnification, less spreading, more of Andromeda inside the view at once. The best instrument for a wide, soft target is very often the least impressive one in the house. For now, hold on to the honey. Because it explains the pattern we noticed in the last chapter, the one that seemed like an odd coincidence. It is not a coincidence at all. It is the same fact stated twice. Anything that presents itself as a point concentrates its light and looks bright. Anything that spreads itself across degrees divides that light over a wider area, and every part of it arrives thinner. The sky is especially good at hiding large, diffuse things, and Andromeda is the widest of them that belongs to somewhere else. So when we ask why Andromeda, 6 moons wide, looks like a thumbprint, we now have the first real answer, and it has nothing to do with how far away Andromeda is. Distance is not the villain here. The villain is spreading. 1 trillion stars deliver a quantity of light to your eye that is genuinely substantial, and then hand it to you smeared so thinly across so much sky that most of it fails to register. The honey is on the table. All of it? You simply cannot see it from where you are standing. And now that we know your eye is working against a thin wash of light, we should ask what else is competing for the same wash. Because Andromeda's faint layer does not arrive into perfect darkness. It arrives into a sky that, for most people alive today, is not dark at all. There is an assumption buried in everything we have said so far, and it is time to take it out and look at it. We have been talking as though the night sky were black, and Andromeda's faint wash were arriving into nothing. For most people listening to this, on most nights, that is simply not true. Go outside in a city and look straight up. The sky is not black. It is a kind of dull orange-gray, or a washed pale blue-gray if the streetlights have been changed recently, and it has a texture to it, like a wall that has been painted over too many times. That color is your own town's light, thrown upward, bouncing off dust and water in the air, and coming back down at you from every direction at once. Andromeda's thin wash has to be brighter than that in order for you to notice it. And in a city, it is not. This is the second answer, and it is the one that has changed most in a single human lifetime. Andromeda did not get fainter. The background got brighter. Think about trying to hear a whisper. In a silent room, a whisper from across the space is perfectly audible. You might even be able to make out the words. Now have someone leave a radio on, low, in the corner. The whisper has not changed. The person is speaking exactly as loudly as before, but there is now a floor of sound underneath everything, and the whisper has sunk beneath it. You do not hear a quieter whisper. You hear nothing. That is sky glow, and for something like 80% of the people alive today, the radio is on, and Andromeda is the whisper. There is a scale for this, made by an amateur astronomer, and it runs from 1 to 9. A 9 is a city center, where the sky holds a few dozen stars, and the rest is a bright gray lid. A 5 is a suburb, where you can find the brighter constellations and not much between them. A 1 is a genuinely dark site, a desert, a high plateau, an island. There the sky has real depth to it. You can see your own shadow cast by starlight, and the number of visible stars jumps from 100 or so to several thousand. Andromeda is technically visible from a suburb on a good night, if you know precisely where to look and you have been outside long enough. In a city center, Andromeda is gone entirely. Not faint. Gone. And even where Andromeda is visible, what you are seeing is being clipped. Remember, the outer parts are already below the bar your eye can register. Raise the background, put the radio on, and the bar goes up. More of Andromeda falls below it. The smudge shrinks. From a dark sight, that smudge might be 2 or 3 times the width of what a suburban observer sees, and it is not because the suburban observer has worse eyes. It is the same Andromeda being eaten from the edges inward by the glow of a town. So, the size of Andromeda in your night sky is not one number. It depends on where you are standing. The full extent is what is up there. What you personally can see might be 1 degree, or half of one, or nothing at all, and that range is set almost entirely by how far you are from other people's lighting. Put it plainly, for most of the human beings alive right now, Andromeda has already been switched off. Not by anything that happened to Andromeda, by lamps pointing the wrong way in the last 70 years. There is a version of this that is easy to make gloomy, and I would rather not. So let me point at the other side of it. Everything that has been lost here was lost in about 70 years, which is nothing. And unlike almost every other thing we have done to this planet, it is instantly reversible. Sky glow does not accumulate. It does not linger. There is no half-life to wait out. The night is not damaged. It is only covered. Switch off a town and the sky comes back that same night, whole, exactly as it was, with Andromeda exactly where it has always been, and nothing missing. People discover this during power cuts, and there is a particular kind of report that comes out of those nights, of neighbors standing in the street, looking up, asking what the cloud is. The cloud is our own galaxy. They had simply never seen it. And Andromeda was up there too, on those same nights, for anyone who knew where to turn their head. So when we ask how big Andromeda looks tonight, the honest answer has to include where you are. That enormous patch of sky sits above much of the northern half of this planet. How much of that width reaches you is a local matter decided by lamps. And that leaves one more variable, the last one that belongs to us rather than to Andromeda. Because even under a perfectly dark sky, with the radio off and the whisper clear, there is still the instrument doing the listening. 2 of them, in fact, about 6 centimeters apart, and they turn out to be far stranger and far more capable at night than most people ever discover. We have blamed the spreading of Andromeda's light, and we have blamed the lamps in the street. That leaves the third suspect, and it is the one standing closest to the crime. Your eye is not one instrument. It is 2, sharing the same lens, and they take turns. Across the back of your eye, there are 2 different kinds of light-catching cell. One kind handles color and fine detail. They are packed most densely into a small patch at the very center of your vision, the spot you are using right now to read a word or to find a face in a crowd. They are magnificent in daylight, and they are almost useless in the dark. They need a generous amount of light before they will report anything at all. The other kind cannot see color. They give you no fine detail. What they have instead is sensitivity, enormously more of it, and they are spread everywhere across the back of the eye, except that central patch. So the arrangement you are carrying around is this. In the middle of your vision, sharp, colorful, and blind at night. Everywhere else, soft, gray, and exquisitely sensitive. This is a camera loaded with 2 films at once, and only one of them works after dark, and it is not the one loaded in the middle. Which explains the trick from the first chapter. When you look straight at Andromeda, you are aiming Andromeda at the patch that needs light and does not have it. When you look slightly to the side, Andromeda falls onto the sensitive cells, and it grows and brightens, because you have finally pointed the right instrument at it. Astronomers call this averted vision and treat it as a skill, which it is. It feels wrong to do. Every instinct you have says, look at the thing. And the sky rewards you for disobeying that instinct every time, and rewards you more with Andromeda than with almost anything else, because Andromeda has more hidden width to give back than anything else you can reach. Then there is the other half, which is slower and which almost nobody gives themselves. Those sensitive cells do not switch on the moment you walk outside. They rebuild a chemical, and the rebuilding takes time. After 5 minutes outdoors, you have some of your night vision. After 10, you have more. The curve keeps climbing for a good half hour, and it does not fully finish for something like 40 minutes, and the difference between the beginning and the end is not small. It is a factor in the thousands. Almost nobody waits. People step outside, glance up for 90 seconds, decide the sky is empty tonight, and go back in. And they are not wrong about what they saw. They looked at the sky with an instrument that had barely started warming up, and Andromeda was above them the entire time. And it is fragile in a particular, annoying way. One bright look at a phone can set that adaptation back significantly, and the brighter and longer the exposure, the more time your eyes need to recover. This is why serious observers use red light, and why the whole culture of the thing has a slightly monastic feel to it. The rule is simply no bright light for a long time if you actually want to see Andromeda. So consider what the honest requirements are for a person who wants to see how large Andromeda really is. Get away from town lights. Wait for a moonless night, because the moon is itself a source of sky glow and washes out everything faint, Andromeda included. Go outside and stay outside for at least half an hour without looking at anything bright. Let your eyes finish. Find the crooked W, count down and across to the right patch of sky. And then, having found Andromeda, do not look at it. Look just to one side and let the edge of your vision do the work. Do that, and the thumbprint opens out. Andromeda becomes an oval, clearly longer in one direction than the other. On a genuinely dark night, with patience, people report seeing Andromeda stretch across 2 degrees or more, 4 moons, and they describe the moment with a particular sort of quiet, because they have just watched a smudge turn into a structure. That is a real thing that a person can do with no equipment in one evening for free. So when we ask how big Andromeda is in our night sky, we have now taken the question apart completely, and it has three separate answers depending on which part of the chain you ask about. Andromeda delivers its full apparent span. Your location and its lamps decide how much of that survives the journey down. And your own eyes and how much patience you gave them decide how much of what survives actually gets seen. Andromeda is the only part of that chain that never varies. Andromeda has been offering the whole of that width whenever it rises into a dark enough sky. For the whole time there have been eyes on this planet to offer it to. And there is one more thing to say about your eye before we leave it, because it is easy to miss, and it is the most remarkable part. Those sensitive cells at the edge of your vision are, at their limit, capable of responding to a very small number of particles of light. Not a stream, a handful, right at the edge of the physically possible. Which means that when you stand in a dark field and catch Andromeda out of the corner of your eye, you are not looking at a picture of Andromeda, or a representation of it, or a rendering. Individual particles of light, which left Andromeda before there was anything human on this planet, are ending their 2.5 million year journey by striking a cell at the back of your eye and being absorbed. The journey ends inside you. That is the actual mechanism. Which raises an obvious question about all those photographs, the glowing spirals, the colors, the dust lanes. If the eye is that limited, where do those come from? Are they real? And if they are, why does nothing up there look like them? You have almost certainly seen a photograph of Andromeda. A great tilted spiral, dust lanes cutting dark curves through it, the core burning gold, blue star-forming regions strung along the arms like lights on a distant pier. And then you have gone outside, if you ever have, and seen gray. There is a temptation to feel cheated by that, and I want to head it off, because the truth is better than the complaint. A photograph is not a picture of a moment. That is the whole thing, right there. Your visual system integrates faint light only over relatively short intervals, and whatever arrives inside one of those intervals is what you get. Light that arrives too thinly to register in one of them is simply lost, and the next one starts empty. A camera does not have to throw it away. A camera can be told to keep the shutter open and hold on to everything that lands, adding it up for as long as you like. 10 seconds. 5 minutes. 12 hours spread across many nights. Put a bucket out in a light drizzle and glance at it. Nothing. The rain is far too fine to see collecting. Leave the same bucket out all night and come back in the morning, and there is water in it, real, measurable water, from a rain so light you could not see it falling. That is a long exposure. Nothing is invented. Nothing is added. The camera simply refuses to keep emptying the bucket the way your eye does, which is why the photograph shows the whole of Andromeda and your eye shows the core. The outer regions of Andromeda were arriving the entire time. They were below your eye's threshold in any single instant, and they were never below zero. Given a bucket and a night, they add up to a galaxy. The colors have a similar answer, and it is the same kind of honest. Those sensitive night cells of yours do not do color at all. So the grayness you see is not Andromeda being gray. It is your night vision being colorless. The color is genuinely there, arriving with everything else, and you are simply not equipped to receive it after dark. A camera has no such limitation. It can accumulate enough signal in separate color channels to recover color your night vision cannot. What is fair to say is that photographs are usually stretched. The range between Andromeda's blazing core and its faintest outer wisp is so enormous that no screen and no sheet of paper could show both. So the astronomer compresses that range, brings the bright down, lifts the faint up, so that the whole thing can be seen at once. That is a decision, and a good one, and everybody making those images will tell you they made it. So the honest sentence is this: the photograph shows you something true about Andromeda that you cannot see. The eye shows you something true about Andromeda that no photograph can give you. And the second half of that is worth defending because it gets forgotten. When you stand in a cold field and find Andromeda with the edge of your vision, you are not looking at an image of a thing. You are in the presence of the thing. The light is arriving now, on your face, in real time, at the end of an unimaginable journey, and it is ending in you. There is no screen. There is no processing. There is no delay other than the 2.5 million years, which was never anybody's fault. Photographs are extraordinary, and I would not be without them. But nobody has ever stood in a field at 2 a.m. and been quietly changed by an image on a screen, in the way people are changed by finding Andromeda themselves for the first time. There is one more thing the photographs quietly do, and it is worth knowing before we move on. Many widely shared images of Andromeda are framed tightly around the bright disk, because that is where the interesting structure is, and because a photograph has to end somewhere. So even the pictures, which are honest about brightness, can make its angular extent easy to underestimate. They show you Andromeda with its outskirts trimmed off, framed like a portrait, and your sense of how much sky Andromeda occupies comes out smaller than the truth all over again. The very few images that keep the whole field, with the constellation stars left in for scale, are startling in a way the famous ones are not. You see the spiral, and then you see how much sky sits inside the same frame, and the 6 moons suddenly stop being a claim and start being obvious. So when we ask how big Andromeda is in our night sky, the photographs turn out not to be the enemy of the question at all. They are simply another instrument reporting from the same place, with a longer memory than we have. The camera says 3 degrees. The eye, on a good night, in a dark place, with 40 minutes of patience, says 2. And on a bad night in a bright town, the eye says nothing, and the sky is exactly as full as it always was. Everything so far has been about the present tense, your eye, your sky, tonight. But Andromeda has been above those skies for far longer than there have been roofs, and people have been looking up the whole time. which means somebody, at some point, must have been the first person to write Andromeda down. They were. His name has survived, and what he called it tells you almost everything about how something 6 moons wide can hide for 1,000 years in plain view. Around the year 964, in Persia, an astronomer sat down to correct the star catalog he had inherited. His name was Abd al-Rahman al-Sufi, and the book he produced is one of the great quiet achievements of the medieval world. He went through the constellations one by one, checked positions, corrected brightnesses, and recorded the local Arabic names alongside the Greek ones. He made careful drawings as well. Each constellation was shown twice, once as it appears in the sky, and once mirrored as it would appear on a globe. And somewhere in the section on the constellation Andromeda, he noted something that was not a star. He described it as a little cloud. That is the first surviving written record of Andromeda. Not a discovery, exactly. The phrasing suggests it was already known to the people around him, the way a landmark is known, but the first time somebody wrote it down and left the note where we could find it, a little cloud. Think about how modest that is. It is not wrong. It is exactly what it looks like. It is the same description a person would give tonight, standing in a field with no idea what they were looking at. And it sat there, in the margin of astronomy, for the next 6.5 centuries. It appeared in catalogs. It got listed. Nobody could do anything with it, because there was nothing to be done. It was a small gray patch, and every instrument anyone had made it a slightly larger small gray patch. Then, in 1612, a German astronomer named Simon Marius turned one of the new telescopes on it and wrote the first description made through glass. He said it looked like a candle seen at night through a horn, the translucent sheet that was used for lantern windows before cheap glass. A soft, spreading, edgeless glow with a brighter middle. Which, again, is exactly right, and again does not get anybody any closer. This is the thing to sit with in this chapter. For something like 700 years, the best minds available looked directly at a galaxy of 1 trillion stars, using the best instruments there were. And they could truthfully report only this: a small pale smear, slightly brighter in the middle, in the constellation of Andromeda. They were not stupid. They were not careless. They were looking at a wash of light spread across 3 degrees of sky, and there was no method in existence, anywhere, that could turn that wash into a fact. There is something worth pausing on in that phrase, a little cloud. Al-Sufi was one of the most careful observers of his age. He was working under skies with no streetlights anywhere on the planet, from a latitude where Andromeda rides high, with eyes that had spent every night of his adult life adapting to the dark. His skies were extraordinarily dark by modern urban standards. And what Andromeda gave him, under skies most people alive today have never seen, was a little cloud. That is how thoroughly the spreading winds. Dark sky, practiced eyes, endless patience, and Andromeda still presented itself mainly as a small pale cloud, with much of its faint outer light remaining difficult to see. It is worth saying, too, that al-Sufi almost certainly was not the first person to see Andromeda. He was the first to write it down in a book that survived. People had been looking at that patch of sky for as long as there had been people. In a world with no artificial light at all, Andromeda would have been an unremarkable but perfectly visible feature of the autumn sky. Shepherds, sailors, anyone who spent their nights outdoors would simply have known it was there without any particular need to explain it. We have no record of what any of them called Andromeda, because none of them wrote it down, or because what they wrote did not survive. Thousands of years of quiet familiarity with one of the widest distant galaxies a northern observer can see with the unaided eye, and the whole of it is gone. And what we have instead is one line in one book from the 10th century. Later, it acquired a catalog number because a French comet hunter named Charles Messier was compiling a list of fuzzy objects that were emphatically not comets, so that he and others would stop wasting their nights on them. Andromeda went into that list. Its number is 31, and you will still see it written that way in books, which is why some people call it M31. That is worth a pause, because it is quietly funny. One of the widest, distant galaxies a northern observer can see with the unaided eye entered the modern scientific record as an item on a list of things to ignore. So when we ask how big Andromeda is in our night sky, history gives an answer that is stranger than any measurement. For most of the time humans have been writing things down, the answer was small. Small, faint, listed, catalogued, and set aside. A note in the margin of a book about the real subject, which everyone agreed was the stars. And that judgment held for 950 years after al-Sufi wrote it down. Then, in the space of about 3 years in the 1920s, it collapsed completely, and the little cloud turned out to be one of the most important objects in the history of our understanding of where we live. The argument that did it was so heated that it had to be staged as a formal debate, in a museum, in front of an audience, with each side given a fixed amount of time. By 1920, the little cloud had a problem attached to it, and the problem had split astronomy into two camps that could not both be right. Everybody agreed on what could be seen. There were these spiral-shaped smudges scattered around the sky. Andromeda was the largest and brightest, but there were hundreds of others, faint pinwheels in every direction. Photography had finally got good enough to show the spiral shape clearly. That was not in dispute. The dispute was about one word: how far? One camp said, "These are inside our own system. Clouds of gas, condensing, perhaps forming into new solar systems. Nearby, small, and part of the single great collection of stars that is everything there is." The other camp said, "No. These are other galaxies. Whole separate systems of stars, as large as our own, unthinkably far away, and the universe is therefore not one collection of stars, but a vast dark space with countless collections scattered through it. Those are not two versions of the same picture. They are two different universes. and the entire question turned on a single unknown number, the distance to a smudge. Imagine standing in thick fog and seeing a light. Is it a bicycle lamp 20 meters away, or a lighthouse 10 kilometers off? You cannot tell. The two look identical from where you stand. Brightness alone will never answer it, because brightness is the product of two things: how much light the thing makes, and how far away it is, and you only have the one measurement. That is the whole difficulty in one image, and it had been unresolved for the entire history of the subject. So in April of 1920, in Washington, the two positions were put on a stage. Harlow Shapley argued for the small universe. Heber Curtis argued for the large one. Each had good evidence, and each had evidence that was quietly wrong, and the audience went home without a verdict, because there was no verdict available. It has been called the Great Debate ever since, and the thing that makes it worth telling on a night like this is not who won. It is what it felt like at the time. These were careful people, at the top of their subject, and the question in front of them was not a technical detail. It was, is everything we can see essentially all there is, or is it one island among an unknown number of others? And the object that decided it, the one everything hinged on, was the faint gray oval above your roof. The one you can see tonight with your own eyes. The one Al-Sufi called a little cloud. There is something worth holding on to there. Every generation has this, a thing sitting in plain view that is completely ordinary, right up until someone finds the method that makes it speak. It is not hidden. It is not locked away. It is simply mute until a technique arrives that can ask it a question it is able to answer. For Andromeda, that technique already existed by 1920. It had been published 8 years earlier. And it had come from a place almost nobody in that debating hall would have thought to look. A room full of women in Massachusetts, paid 25 to 30 cents an hour to examine photographic plates. One of them was named Henrietta Swan Leavitt. Her job was to catalog variable stars, the kind that brighten and dim on a cycle, on plates taken of the southern sky. She went through thousands of them. And in doing so, she noticed something that nobody had asked her to look for. Among a particular type of variable star, the ones that took longer to complete their cycle were reliably brighter. Not roughly. Precisely. In a relationship, you could plot as a line. That sounds like a small piece of bookkeeping. It is one of the most consequential observations of the century. Because it means that if you find one of those stars and you time how long its cycle takes, you know how much light it is actually producing. And once you know how much light a thing is actually producing, and you can measure how much of that light is reaching you, the distance falls out. The fog problem is solved. You have found a lamp with its wattage printed on the side. So when we ask how big Andromeda is in our night sky, the answer in 1920 was still, formally, nobody knows, because size in the sky is only half a measurement. 3 degrees of sky looks exactly the same whether it is a nearby cloud or a distant continent of stars. Without the distance, the number means nothing at all. The tool to fix that was sitting in the literature, published, waiting. And a few hundred miles from that debating hall, there was a new telescope, the largest in the world, and a man who was about to point it at the little cloud and take the plate that would help end the argument. In October of 1923, on a mountain in California, Edwin Hubble took a photographic plate of Andromeda through a telescope with a mirror 100 inches across, the largest that had ever been built. He was hunting for novae. A nova is a star that flares up suddenly and then fades, and if you can catch enough of them, you can make rough estimates of distance. Reasonable work. Nobody's idea of a revolution. He found what he thought was 1 on the outer part of the spiral and marked the plate with an N. Then he went back through the older plates of the same region, comparing, and found the same star flaring on earlier nights, and fading, and flaring again, on a cycle. It was not a nova. It was a variable, the exact type Leavitt had characterized. And because it was on a cycle, and because the cycle could be timed, its true brightness was no longer a mystery. It had a maker's mark. It said how bright it truly was. On the plate, Hubble crossed out the N and wrote VAR with an exclamation mark. That plate still exists. You can see a photograph of it. A crossed-out letter and 3 letters written over the top, in ordinary handwriting, on an ordinary night, by a man who had just realized what he was holding. The number that came out was around 900,000 light-years. We now know that was too small. The calibration had a flaw in it that would not be found for another 30 years, and the real figure is closer to 2.5 million. But the error did not matter in the slightest for the question at hand. 900,000 was already so far beyond the size of everything anyone thought existed that the argument was simply over. Andromeda was not a cloud in our system. It was another one. A separate galaxy, comparable to ours, unimaginably far away, and there were hundreds of other smudges in the sky that must therefore be the same. The universe had been one island. In the course of identifying that one variable star, it became an ocean, with islands scattered through it as far as any instrument could reach. There is a detail in this story that I find hard to let go of. Shapley, who had argued for the small universe, received a letter from Hubble telling him the result. He read it and said to a colleague standing nearby that this was the letter that destroyed his universe. Not my theory. His universe. He had been living in one, and now he lived in another, and he found that out standing in a corridor, reading a letter. And the object that did that to him is above your roof tonight, and it is 6 moons wide, and if you go outside and let your eyes adapt, you can find it yourself in about 40 minutes. It is worth being clear about what Hubble had actually done, because it is easy to make it sound like luck. He had not found a new object. Andromeda had been in catalogs for 1,000 years. He had not built the technique either. Leavitt had done that, and been dead for 2 years by the time it was used here. What Hubble had was a mirror large enough to pick out one individual star inside Andromeda, in among the general glow, and to follow that one star's brightness night after night until it confessed what it was. That is the whole trick. To measure Andromeda, he had to stop looking at Andromeda and start looking at a single point of light inside it, and let that point speak for the whole. And it worked, because Andromeda is close. Of all the spiral smudges in the sky, Andromeda is the nearest large one, and one of the best places where telescopes of that era could resolve individual luminous stars at all. Every other spiral was too far, too small, too smoothly blended. The argument about the size of the universe was settled using the one object that was near enough to be taken apart, and that object is the same faint oval you can find above your roof with nothing but patience. So let us close the loop that has been open since the beginning of tonight, because we can finally do it properly. We had the angle it covers. That was never in doubt. The ancients could have measured it if they had thought to try. What we did not have was the second number, and without the second number, the first one was a shape with no meaning. Now we have both. 3 degrees across, 2.5 million light years away. And with those two numbers together, you can work out how large the thing actually is. Not how much sky it covers, but its true extent, in the way you would measure a country. That calculation is straightforward, and the answer is going to be one of the largest numbers we say tonight. But before we do it, I want to stay with the distance a moment longer, because we have been saying 2.5 million light years, as though it were simply a large number. And it is not simply a large number. It is a length of time. And what was happening on this planet while that light was in transit is worth walking through slowly, because it is the part of tonight that people remember in the morning. 2.5 million years. The number is easy to say and impossible to feel. So let us not try to feel it all at once. Let us walk it. Start with something you can hold. The light from the moon takes a little over a second to reach you. When you look at the full moon, you are seeing it as it was 1 second ago, which is close enough to now that it makes no difference to anyone. The sun takes about 8 minutes. That gap is already strange. If the sun were somehow switched off, you would have 8 minutes of ordinary afternoon before anybody knew. But 8 minutes is still a human amount of time. It is a walk to the shop. The nearest other star is 4 years away. Light that leaves it tonight arrives here when a child born tonight is starting to speak in sentences. Now we have left anything intuitive behind. Cross to the far side of our own galaxy, and you are talking about tens of thousands of years. Light that set out when there were people painting animals on cave walls by firelight and had not yet invented agriculture. And Andromeda is 2.5 million. So here is the walk. The light arriving on your face tonight left Andromeda at a moment when nothing walking on this planet would have looked like a person to you. There were creatures standing upright on the grasslands of East Africa, in small groups, with brains a fraction of the size of yours. Striking one stone against another to make an edge was already an old skill by then, older than the light now reaching you. That is the moment of posting. That is when the letter went into the box. And then it traveled. It traveled through the whole of the ice ages, through the arrival of fire, through the first burials, the first paintings, the first words. It was still in transit when the last mammoth died. It was still in transit when the first field was plowed, when the first city wall went up, when the first mark was pressed into wet clay to record a debt. It was still traveling through every single thing that has ever happened to us. Every war, every language that rose and was forgotten, every person who has ever lived and died, all of them, without exception, lived and died while that light was still on its way. It crossed the last of the distance during your own lifetime. The final stretch, the last few decades of the journey, happened while you were being born and growing up and becoming whoever it is you are now. And tonight it finished. On your face. In your garden. While you stood there, thinking about whether you should have brought a warmer coat. And it will keep arriving after you. There is light from Andromeda that is in flight right now, somewhere out in the dark between the two galaxies, that will not land here for another 1,000,000 years. It has already left. It is already committed. Nothing can stop it or turn it around. And whatever is standing on this planet when it arrives, if anything is, will receive a picture of Andromeda as it looked 1,000,000 years after the one you are receiving tonight. Andromeda has been sending, without pause, into every direction at once, for the whole of its existence. Tonight, you happen to be standing in the path of one particular sliver of that. Now, notice that this is true of the smudge you can barely see. But it is also true of the parts you cannot. The outer regions of Andromeda, the parts spread across the full width, the parts that fall below what your eye can register, are delivering light to you on very nearly the same schedule. They are not late. They are not absent. All of it is arriving from roughly the same ancient epoch, light that set out around 2.5 million years ago. Your face is being lit, right now, by all of it. The whole 6 moons' width. You simply do not have the equipment to notice. That is the thing that most changes how the smudge feels, I think. Not the size on its own, and not the distance on its own, but the two together. The entire enormous width of it is arriving, and has always been arriving. The only reason it seems small and far and irrelevant is a limitation in the last 2 centimeters of the journey. So when we ask how big Andromeda is in our night sky, we can now say something that would have been meaningless at the start of tonight. It is 3 degrees wide, and the light arriving from it is 2.5 million years old, and both of those facts are landing on you at the same time, together, continuously, whether or not you go outside to collect them. We have the 2 numbers now. Angle and distance. Which means we can finally do the piece of arithmetic that turns them into a size, an actual, physical extent, the kind you could compare to something. And when we do, the number that comes out is going to force us to admit that everything we have measured tonight was only the part that glows. Let us put the arithmetic down for a while. It will still be there. We have been working quite hard tonight, in the gentle way that this sort of thing is hard. Degrees and fingernails. Spread out light. Cells at the back of an eye. Men arguing in a hall in Washington. A crossed out letter on a photographic plate. For a stretch now, no new numbers. Nothing to hold on to. Just the thing itself, and you, and the fact that the two of you are in contact. Think about a window left open all night in a room where somebody is sleeping. Nothing dramatic happens at that window. No one comes through it. But all night, the room and the outside are not separate. The temperature of the room slowly becomes the temperature of the night. The sounds outside, a car somewhere, a bird deciding it is nearly morning, wind moving through something, arrive without being invited, and are heard by a sleeping person in whatever way sleeping people hear things. By morning, the room smells like outside. The person did nothing. They were not participating. And yet the night got in, all of it, for hours, because the window was open, and that is what open windows do. Your eyes are like that, and so is your skin, and so is every surface of the room you are in right now. Light from Andromeda is arriving. It has been arriving all evening. It arrived while you were making something to eat, and while you were deciding what to listen to, and while you were settling in. It is arriving now. It will keep arriving after you have fallen asleep and stopped being aware of anything at all. It will still be arriving in the morning, when the sky is too bright for you to see it. The sky being bright does not stop the light. It only stops you noticing. That is worth resting in for a moment. The delivery does not depend on you. It is not an achievement to receive it. There is nothing to get right. Somewhere above your roof, above the cloud, if there is cloud, past everything, that soft, enormous oval is pouring out light in every direction at once, as it has done without interruption for longer than there has been a planet under your feet. A tiny sliver of that outpouring happens to be aimed at this world. A tiny sliver of that sliver happens to be aimed at the patch of ground where you are lying or sitting. And it arrives and lands and is absorbed. And that is the end of a journey that began before anything on this world had a name. It does not need you to be looking. It does not stop when you close your eyes. It does not require a dark sky, or a good night, or a warm coat, or any patience at all. Those things are only required for noticing. The receiving happens anyway. There is a kind of comfort in that which is difficult to get from anywhere else. Most things in a life require you to participate. You have to notice them, or attend to them, or be present for them, or they do not happen. This does not. This is simply true of the room you are in, and of every room you have ever been in at night, and of every night of your life, including the ones you do not remember. You were being rained on by an ancient galaxy while you were learning to walk. You were being rained on while you were at school. You were being rained on during every difficult year and every good one, and on the nights you could not sleep, and on the nights you slept so well you lost the whole 8 hours in a single blink. None of it was ever announced. None of it was ever withheld, and it will go on. Tomorrow night, and the night after, and on nights long past the point where anyone remembers that any of us were here. So, no numbers for a while. No degrees. Nothing to work out. Just a window, left open, all night, in a room where somebody is falling asleep. And the night coming in, quietly, the way it always has. When we pick the numbers back up, and we will, because there are 2 or 3 more things worth knowing, they are going to get larger rather than smaller. Everything we have measured so far has been the part that glows. That turns out to be a small fraction of what is actually out there, and the rest of it covers a piece of sky more than 15 times wider. But not yet. For now, let the breathing get slower. There is nothing to do here. Now, the arithmetic we have been building toward all night. We have an angle, 3 degrees. We have a distance, 2.5 million light years. Put those together and you get a width. This is exactly what a surveyor does with a hillside they cannot walk across. Measure the angle, know the distance, and the size falls out. Do that with the bright oval. 3 degrees is the round figure we have been using all night. The surveyor's figure is a little over 3. Feed that in, and the number that falls out is around 140,000 light years across. Now look up what astronomers actually publish, and you will find figures running from about 150,000 to well over 200,000. That looks like a contradiction. It is not. Those larger numbers are not a different answer to the same question. They are the same arithmetic done over a wider patch of sky, because the surveys that drew the boundary found structure reaching much further out than the oval your eye stops at. Feed a bigger angle into the same calculation, and you get a bigger width. The disagreement was never about the maths. It was about where to stop measuring. And I want to be careful about that range rather than pick a headline figure, because this is one of those places where a number gets repeated so often that it hardens into a fact when it was never quite one. For a long time, the standard figure was around 120,000 light years. Then, in the mid-2000s, a survey done in infrared light found a great deal of structure much further out than anyone had mapped, and the figure jumped to something like 220,000. More recent work, tracing the outer edges by different methods, has come back with numbers nearer 150,000 for the main disk. So which is right? They all are, and the disagreement is not really a disagreement about Andromeda. It is a disagreement about where a galaxy stops. Imagine mapping a city at night from an aeroplane, using only the lights. The center is obvious, a solid, glowing mass. Further out, the lights thin into streets, then into scattered houses, then into the occasional farm with one lamp on. At what point have you left the city? You can draw the boundary at the dense core. You can draw it at the last continuous street. You can draw it at the final isolated lamp. Every one of those is defensible, and they give you wildly different answers, and none of them is wrong. The city does not have an edge. It has a fading. Galaxies are the same, only more so. There is no wall. There is no last star with nothing beyond it. There is a dense middle and arms, and then a slow thinning out that goes on much further than the bright part, and eventually you are counting individual stars in enormous emptiness and calling it the outskirts. There is a second reason the number is soft, and it is worth knowing because it applies to almost every large figure in astronomy. To convert that angle into a width, you must multiply by the distance. And the distance to Andromeda is itself a measured quantity, with an uncertainty attached, a percent or two, depending on the method. A small uncertainty in the distance becomes a proportionally identical uncertainty in the size, automatically, before anyone has even argued about where Andromeda's edge is. So the range you get is really two ranges stacked. One from not knowing exactly how far Andromeda is. A much larger one from not agreeing on where Andromeda stops. This is not a weakness in the science. It is what an honest measurement of an enormous soft-edged object looks like. Anyone who gives you a single confident figure for the width of Andromeda, with no range and no caveat, is quoting a textbook rather than a measurement. And that textbook is quoting one particular survey made with one particular instrument that drew the boundary in one particular place. So the honest sentence is this: Andromeda's bright disk is somewhere in the range of 150 to 200,000 light-years across. And the reason nobody can be more precise is not that the measurement is bad, it is that the question is soft. Either way, it is larger than the galaxy we live in. Not enormously larger, the two are comparable, and by mass, they may be closer than they look, because most of what a galaxy weighs is not the part that shines. But in sheer extent of stars, Andromeda is the bigger of the two, and it is the largest galaxy in our immediate neighborhood. And now put that back against the sky. 3 degrees. 6 moons. That is what 140,000 light-years of stars looks like from 2.5 million light-years away. You can go outside and hold up 3 fingernails and cover it. That gesture, 3 fingernails at arm's length, covers a structure of 1 trillion suns spanning 140,000 light-years. Nothing about that is a trick or an exaggeration. It is simply what those two numbers mean when you put them next to each other, and it is the single best argument I know for why the sky deserves more attention than it gets. So when we ask how big Andromeda is in our night sky, we can now answer in both languages at once, and they finally connect. In the language of your hand, 3 fingernails. In the language of the thing itself, 140,000 light-years of stars, and more than that, if you count the faint outskirts the surveys reach. Which brings us to the sentence I have been holding back all night. Everything we have measured, the 3 degrees, the fingernails, the 140,000 light-years, is the part that glows. It is the streetlights. And it turns out that around that lit region, there is something enormously larger. It does not glow. It was only mapped properly a few years ago, and it is so vast that if it did glow, it would reach from directly overhead more than half the way down to the horizon. Galaxies are not sharply edged objects floating in a vacuum. They sit inside vast, thin envelopes of gas, hot, tenuous, nearly invisible, extending far past anything you would call the galaxy itself. For a long time this was suspected and could not be measured, for a reason that will sound familiar by now. The gas is far too faint to see. It gives off almost nothing. So astronomers did something indirect and rather beautiful. Instead of trying to see the gas, they looked at bright objects far beyond it, quasars, the blazing cores of distant galaxies. Then they studied the light arriving from those, looking for the specific fingerprints that gas leaves behind when it passes through. It is a bit like working out the shape of fog by watching how a distant headlight dims and colors as a car drives through it. You never see the fog. You see what the fog does. Doing that around Andromeda, with a couple of dozen background quasars scattered around it, produced a map of something enormous. The halo of gas around Andromeda extends roughly 1 million light-years out from its center in every direction. In some directions, along some sightlines, the traces run further still. Set that against the bright disk we were just discussing. 140,000 light-years across the part your eye is shown, 200,000 at the widest anyone draws it. The invisible part is something like an order of magnitude larger than the visible part. The galaxy you can photograph is a bright knot near the middle of something vastly bigger and almost entirely dark. Now do the thing we have been doing all night. Put it back on the sky. If that halo glowed, if it were bright enough for a human eye, it would not be 6 moons across. It would be something like 50 degrees across. 100 full moons, laid side by side in a line. More than half the distance from directly overhead, all the way down to the horizon, filled by one single object. On the clear nights of your life, when it was up, you have been standing under that. Not near it. Under it, its outer regions already reach a substantial fraction of the way across the gap between Andromeda and our own galaxy. Which means that, in the loosest and most honest sense, the outskirts of Andromeda and the outskirts of our own galaxy may not be separated by empty space at all. Their extended gaseous halos may already overlap, depending on how those halos are defined. That is a genuinely odd thought to have while standing in a garden. There is a version of this I want to avoid, which is the version that makes it sound spooky. It is not spooky. That gas is thinner than the best vacuum any laboratory on this planet can produce, far thinner. If you stood in the middle of it, you would notice nothing whatsoever, forever. It is not a presence. It is a statistical fact about where atoms are. But it is real, and it is measured, and it is the reason the question we started with tonight has no clean answer. Because when you ask how big something is in the sky, you are quietly assuming it has a size. That there is a thing with an outside and a place where it stops. And the closer you look at any large object in the universe, the less that assumption survives. The stars fade out gradually. The gas thins farther out beyond them. There is no sharp edge, only a gradient, dense here, thinner there, until eventually the halo blends into the surrounding intergalactic environment. Which means Andromeda is not 3 degrees across. That is simply where we decided to stop counting, because that is where it stops being bright enough to bother us. Like a streetlight in fog. There is the lamp, hard and obvious. There is the cone of glow around it, softer. There is the general lifting of the darkness, for some way beyond that. And there is no line, anywhere, where the light of that lamp can be said to end. There is only the point where your eye gives up. So when we ask how big Andromeda is in our night sky, the deepest answer we can give is far larger on the sky than its bright disk, and fading. The bright part is 6 moons wide. The part we can detect but not see is some 50 degrees of the sky above you. And the part beyond that has no edge at all. It simply thins out until it is indistinguishable from the space between galaxies, which is itself not empty, only emptier. Which raises the last of the what-if questions, and it is the one people ask as soon as they understand the width. If it is that big, and it is only invisible because it is faint, what would the sky look like if it were not? So let us build the sky that almost exists. Everything required for it is already in place. The galaxy is there. Its light is arriving. The 3 degrees are real and measured. The only missing ingredient is brightness. The light arriving is spread too thin for a human eye, and that is the entire difference between the sky you have and the sky I am about to describe. Change nothing else. Do not move it closer. Do not make it larger. Simply imagine that every part of it arrived bright enough to see, the way its core almost does. Here is what you would walk out into. Rising in the east, on autumn evenings, an oval of pale light. Not a disk, an oval, clearly longer one way than the other, tilted at an angle, wide enough that 3 little fingernails held at arm's length would only just span it. 6 full moons could be laid across it in a line and would not quite reach. It would have structure. Dark lanes curving through it where dust blocks the light from behind. A dense, bright middle, too crowded to resolve. And arms, actual arms, sweeping out and around, fading toward the edges into something with no boundary you could point at. It would rise and set. It would be higher in the sky in some months than others. People would have a word for the season when it stands overhead at midnight, the way we have words for the seasons of other things. And it would be silent, and it would not change, and it would be a fixture of the night for anyone living where it rises. Try to imagine what would have been built under a sky like that. Every religion, every calendar, every myth about where things come from, every child asking what it is. Astronomy would not have needed to be invented. It would simply have been the obvious thing to think about, the way weather is. It is like owning a painting that is too big for the wall you have. The painting exists. It is not smaller than it is. You have simply hung it in a room that cannot show it, and so you see the middle third and remember it as a modest picture. There is a second version of this sky worth building, and it is smaller and stranger and closer to home. Forget brightness. Keep everything exactly as it is. Instead, imagine only that people were told that on the first clear night of every autumn, every child on the northern half of this planet was taken outside and shown the crooked W, walked down and across to the right patch of sky, and left there for 40 minutes until their eyes finished adapting and Andromeda came out of the background. That costs nothing. It requires no change to the universe and no change to human eyes. It requires an evening, and it would produce a species with a completely different relationship to the sky. Everybody would have a personal memory of finding one of the largest things they will ever see, and of discovering that it had been above them the entire time without anybody mentioning it. The reason that does not happen is not secrecy, and it is not difficulty. It is that Andromeda does not demand anything. It does not move, it does not flash, it does not appear suddenly, and it never announces itself. Everything that captures human attention automatically is either bright, or sudden, or moving, and Andromeda is none of those. Andromeda is enormous and patient and entirely silent, and those are precisely the qualities that make something easy to overlook. It has taken 1,000 years, a photographic plate, a debate in a museum, and an argument about the size of the universe for us to work out what Andromeda is. And still, tonight, the ordinary experience of Andromeda for almost everyone alive is nothing. An empty patch of autumn sky above the roof. And now, the part that turns this from a thought experiment into something stranger. That sky is not fictional. It is this sky. Everything I have just described is above your roof tonight, at exactly that size, in exactly that orientation, with exactly those dust lanes, and exactly those arms. Nothing about the description was invented. The only thing I changed was your eye. We are not imagining a different universe. We are imagining a slightly different retina, which means that countless generations of people living where Andromeda could be seen have spent their whole lives under an enormous tilted spiral of 1 trillion suns. It hangs in the eastern sky. They looked up and they saw nothing there. Not because it was hidden, not because it was far, because the light was spread. There is one more turn to this, and it is the one that makes tonight's question have an expiry date on it. We have been treating that oval as fixed, as a permanent feature of the sky, something that will be there for everyone, the way it was there for everyone before us. And on any time scale that matters to us, it is. But it is not fixed. It is moving. And it is not moving away, the way almost everything else in the universe is. It is coming toward us. Almost everything in the distant universe is receding. That is one of the foundational observations of the last century. The further away a galaxy is, the faster it is going away from us, in every direction we look. Andromeda is one of the exceptions, and it is the largest one. Its light comes to us shifted in a way that means approach rather than retreat. The raw shift is large, a few hundred kilometers a second, but most of that is our own sun sweeping around this galaxy, carrying us toward Andromeda's part of the sky. Correct for our own motion, and what is left is Andromeda itself, closing on us at something like 110 kilometers every second. That is a startling figure to say out loud, and a completely unstartling one to experience. 110 kilometers per second is fast enough to cross a country in a heartbeat. Against 2.5 million light years, it is nothing at all. At that rate, the gap closes by roughly 1 part in 100 million over the course of a normal human lifetime. Nobody has ever noticed the smudge getting bigger, and nobody ever will. Picture 2 boats on a very large, very still lake, drifting toward each other at the pace of a slow walk. From either boat, on any given afternoon, nothing is happening. Nobody on board would describe the situation as an approach. And yet, if the lake is large enough, and you are patient enough, the 2 boats may have a meeting in their future. That is roughly the situation, except that the lake is measured in millions of light years, and the afternoon is measured in billions of years. The reason for the approach is straightforward. These 2 galaxies are close neighbors, gravitationally bound to each other, part of the same small group. The general expansion of the universe pulls apart things that are far enough apart for it to win. Locally, on this scale, gravity is still winning, and gravity does what gravity does. Now, the part that most versions of this story leave out, and which I do not want to leave out because it is more interesting than the tidy version. The standard telling is that in about 4 billion years, the 2 galaxies will collide, merge, and become one. You will have read this. It is the version in most books and most films and most of the videos on this subject. It may well happen. It is the most quoted outcome, and it comes from serious work. But it is a prediction, and predictions have error bars, and the error bars on this one are larger than the confident telling suggests. The problem is that a collision depends on the sideways motion as well as the approach. The approach we can measure very well. That is what the shift in the light gives us. The sideways drift is far harder because it means detecting a change of position across a distance of 2.5 million light years over a handful of decades. And a small amount of sideways motion is the difference between 2 boats meeting and 2 boats passing. Recent work that takes more of the neighborhood into account, the pull of other nearby galaxies, and the honest size of the uncertainties, has found that a direct merger within the next 10 billion years is far from guaranteed. Some analyses put it close to a coin toss. So the truthful sentence is this: the 2 galaxies are approaching, and that is measured and not in doubt. A merger remains possible, but the timing and even the eventual outcome are not settled. Anybody who tells you the date with confidence is rounding away a real argument. I would rather give you that than a clean story. The clean story is more quotable. The real one is better because it is still open. It is worth holding on to how ordinary the measurement itself is. Andromeda's approach was first detected in 1912, before anybody knew what Andromeda was, before the debate in the museum, before the photographic plate, before anyone had the faintest idea whether they were measuring a nearby cloud or another universe. Somebody spread out the light from Andromeda, looked at where the dark lines in it had landed, found them shifted the wrong way, and wrote down that this thing was coming toward us rather than away, and then had to wait 11 years to find out what the thing was. So when we ask how big Andromeda is in our night sky, we have to add a word we have not needed until now: tonight. It is 6 moons wide tonight. It was very slightly narrower when the first cities were built, by an amount no instrument of that era or this one could detect. And it would be wider, genuinely, measurably wider, long after everything we can imagine has finished happening. Which gives us one last possible sky to build, a future that follows if those two boats do meet. Because if those two boats do meet, then there is a night, a very long way from here, when that oval does not need any help from anybody's imagination in order to fill the sky. Come forward with me. A long way forward, into one possible version of the future, the one that follows if those two boats do meet. Not the 50 years that a person can plan for. Not the few thousand that our record-keeping covers. Billions. So far ahead that this planet's continents will have finished rearranging themselves several times over, and the sun will be noticeably brighter and hotter than the one you know. In that version, the oval in the eastern sky has been growing all that time. Not visibly, not on any night in particular, but relentlessly, the way a tide comes in without any single wave being the one that does it. Somewhere in there, it would stop being a smudge. There would be a moment, spread across a few million years, which at this scale is a moment, when it became the most obvious thing in the sky. Not something you find with averted vision after 40 minutes in a field. Something you could not avoid, filling a huge fraction of the sky. And it would keep growing. Eventually, it would not have a shape you could point at, because it would not fit inside the part of the sky you can take in at once. You would have to turn your head to follow it from one end to the other. Where the moon is a coin and the sky is a dome, this would be a wall. An enormous tilted band of light with visible structure in it, dust lanes running through it like dark rivers. The whole thing bright enough to transform the night sky so that the landscape underneath would no longer feel truly dark. The night sky would no longer look anything like the one we know. That is the part that is hard to picture properly. Large regions of it could be filled with structured galactic light, soft, textured, and spread from one side of your view to the other. A roof made of light, over everything, for a very long time. And then, in this same possible future, the two would begin to pass through each other. This is where every instinct gives you the wrong picture, so let me correct it, because the correction is the most beautiful fact in tonight's entire subject. Nothing crashes. Galaxies are almost entirely empty. The stars inside them are separated by distances so vast compared to their own size that when two galaxies pass through each other, the odds of any two stars actually striking one another are effectively zero, not small. Effectively zero. If you shrank the sun to the size of an orange, the nearest star would be another orange 2,000 or 3,000 kilometers away. Now imagine two enormous swarms of oranges, spaced like that, drifting through each other. They pass. Everything passes. What would actually happen is gravitational and slow and enormous. The two structures would pull on each other. Arms would be drawn out into long streaming tails of stars, hundreds of thousands of light years long. Clouds of gas, which unlike stars are large and diffuse and do collide, would be squeezed. Squeezed gas collapses, and collapsing gas ignites, so the whole sky would go through an era of furious star formation, lit up with new blue suns being born in enormous numbers. Over hundreds of millions of years the two would settle. Spiral structure is unlikely to survive a merger like that. You cannot stir two pinwheels together and expect a pinwheel. What it could eventually leave behind is a single, much smoother remnant, more elliptical in form than either spiral we know today. A great slow glow of old and new stars orbiting a common center. And whatever is on this planet, or on any planet in either galaxy, would be extraordinarily unlikely to be struck. Moved, perhaps, flung into a wide new orbit, or out into the streaming tail. But direct star-on-star collisions would be vanishingly rare. The whole thing is less a crash than two flocks of birds passing through one another and coming out as one flock. So there is a night, out there in the deep future, when the sky is a roof of light. Nothing is falling. Nothing is breaking. And the largest event this corner of the universe will ever see is happening in complete silence, at a pace no living thing could perceive. And here is why I wanted to bring you all this way for it. That future sky and the sky above your roof tonight are the same object, not a different one. The same faint gray oval you can go outside and fail to see. The same 3 degrees. The same light that has been arriving on this planet since before there were faces. It is not becoming something else. It is only getting closer, and we are only learning to look. And the difference between a thumbprint on cold glass and a roof made of light is nothing more than time and attention. We have gone as far out as we can go. There is nothing beyond this, in this story. So let us come back, slowly, all the way back, to a garden, and a coat that was not zipped up properly, and a question asked at the very beginning of tonight that we can finally answer properly. We asked one question tonight, right at the start, and everything since has been an attempt to answer it honestly. It is 6 moons wide. So why can you barely see it? We have the answer now, and it comes in 3 parts, and none of them is about Andromeda. The light arrives spread out, so thin across so much sky that most of it falls below what an eye can register. The sky it arrives into is no longer dark for most of us, so what little would have registered gets buried under the glow of our own lamps. And the eye, doing the looking, is a daytime instrument with a nighttime attachment that takes half an hour to warm up and that almost nobody gives the time to. 3 answers: spreading, glow, and patience. And Andromeda itself is not on the list. It never changed. It has been offering the whole of itself, the full width, without variation, whenever it rises into a dark enough sky. The smallness was never a property of the thing. It was always a property of the looking. That is the sentence I would keep from tonight, if I only kept one. Because it is not really about a galaxy, is it? That pattern is everywhere, once you have seen it. The things that are easiest to notice are almost always the small bright ones, the point of light, the sharp edge, the thing that arrives concentrated. And the enormous things, the ones that are actually shaping the space you live in, tend to arrive spread out and gradual and below the threshold. They go unnoticed for entire lifetimes, not because they were hidden, but because nothing about them was ever concentrated enough to demand attention. What arrives concentrated gets noticed. What arrives spread out does not. That turned out to be a pattern in the night sky, and it is a fairly reliable pattern in most other things too. There is one more version of the answer, and it is the shortest. How big is Andromeda in our night sky? Bigger than you can see. That is the whole of it. Not bigger than you thought, bigger than unaided vision reveals, for everyone, with no way around it except patience and a dark field and the corner of your eye. Andromeda is one of those objects where the honest answer to how big is not a single number. It is larger than unaided vision reveals, and that limit is on our side. And the second thing worth keeping is gentler. Nothing about tonight required anything of you. You did not have to earn the light. It was already arriving, and it had been arriving your whole life, and it would have gone on arriving whether or not anyone ever explained what it was. The only thing that changed tonight is that you know. And knowing does not add anything to the sky. It only removes something from your side of it, the assumption that what you can see is what is there. Go outside in the autumn some evening, when you have time and no reason to hurry. Find the crooked W. Let your eyes go for half an hour without looking at anything bright. Hold up your little finger and remember that it covers 2 full moons. Then find the faint oval and look slightly to one side of it and watch it open out. You will still see a smudge. That is what it looks like. Nothing tonight will change what it looks like, but you will know that you are covering, with 3 fingernails, 140,000 light years of stars. That the light landing on your face left before there was a human face for it to land on. That the part you can see is the crowded middle of something 6 moons wide and that beyond the part that glows, its enormous, nearly invisible halo of gas reaches across tens of degrees of sky with no sharp edge anywhere, and that all of that is not somewhere else. It is here, now, on your skin, in your garden, in the ordinary dark above an ordinary roof. That is the whole thing. That is what we came for. The measuring is done. The ruler goes back in your pocket, which is to say, your hand goes back in your pocket, and there is nothing left to work out. So let the numbers go now. All of them. The 3 degrees, the 6 moons, the 2.5 million years, the 140,000 light years. You do not need to carry any of them, and you will not lose them by letting go. They will be there in the morning if you want them, and the sky will be there tonight, whether or not you remember a single figure. What is left is simpler and softer and does not need to be understood. Let your breathing get slower than your thinking. There is nothing left to follow. Nothing coming that you need to be ready for. The rest of this is only for the drifting. Above you, past the ceiling, past the roof, past the cloud, if there is cloud tonight, there is a soft, wide oval of ancient light, and it is not doing anything. It is not urgent. It has never been urgent. It has been pouring out light, doing that same slow, quiet thing since long before this planet had oceans. Andromeda is not waiting for anything. It has no appointment. Nothing about it is running late or running early. And it will still be there long after every question anyone has ever asked has stopped being asked. There is nothing you need to do about that. There is nothing anyone needs to do about it. Breathe in slowly and let it go. Let the shape of the evening come apart. The numbers first, they go easily. Then the words. Then the wanting to remember any of it. Andromeda does not require remembering. It will be there tomorrow, whether or not a single thing from tonight stayed with you. Breathe in slowly and let it go. It does not need you to watch it. That was the whole discovery of tonight, that the light arrives regardless. It arrived while you were busy. It arrived on the days that were hard and on the days that were fine. It arrived through every year of your life, and it never once asked whether you were paying attention. It is arriving now, while you lie here. Breathe in and out more slowly than you took it in. Think of the window left open. The room slowly becoming the same temperature as the night. Sounds arriving from outside without being invited. Nothing to do. Nothing being asked. Just an opening, and the night coming through it, all the way until morning. You are the room. Breathe in and out. Feel how heavy your shoulders are, and let them be heavier. Feel where your body meets whatever is holding it, the mattress, the chair, the floor, and let that place take more of your weight than it currently has. There is more weight to give than you think. There always is. Let your jaw loosen. Let your hands stop holding themselves closed. Let the small muscles around your eyes give up the work they have been doing all day without being asked to. Breathe in and out. Somewhere far above the roof, 6 moons wide, older than anything you have ever touched, unhurried, an enormous quiet thing is pouring light in every direction. A small part of that light is falling on the place where you are lying, and it will keep falling all night, whether you are awake to receive it or not. You do not have to stay awake for it. That is the permission this whole night has been leading to. You do not have to stay awake for any of it. It is not going anywhere. Nothing up there ends because you closed your eyes, and nothing up there needs you to keep them open. Breathe in and out. The sky is doing what it has always done. Slowly, without effort, without any need to arrive anywhere. Let your breathing match it. In and out. Heavier now. Slower now. There is nothing to measure. There is nothing to hold. There is only a wide, soft, ancient light above a roof, and a warm, dark room underneath it, and you, somewhere in between, letting go of the day. Rest now. The light will keep arriving. It always has. If you would like more nights like this one, more slow looking at things that are quietly enormous, you are welcome to follow along, or to share this with someone who has trouble sleeping and might like the company. And whenever you need it, this is here. Come back any night at all. For now, let your breathing slow. Let the room be warm and dark around you. 6 moons wide, its light 2.5 million years old, entirely unhurried, and above your roof for as long as you would like it to be. Good night.